Alright, in this video we are going to take a look at this Leetcode problem, which is the best time to buy and sell stock. So let's take a look at the description. The problem statement says that we are given an array of prices where prices at that specific index is the price of a given stock on the ith day. So what we want to do is basically maximize our profit by choosing a single day to buy the stock and choosing a different day in the future to sell that stock. And we are not supposed to calculate the maximum profit that we can achieve from this transaction. And if there is not a possible profit that we can achieve, all we need to do is return 0. So let's go through the examples as well. So given an array where we have these numbers which reflect the stock's price on each day, we need to calculate the maximum profit. And just by looking at it, I can see that I'll purchase it on the lowest on the day where I have the lowest price, which is 1, and I'll sell it on the 5th day, right? And 5th day has 6, so if we calculate the difference between the two, I will get a profit of 5, and that's exactly the output here. So we cannot actually do something like buy on day 2 and you cannot sell on the previous day, because of course you can't travel back in time. So that's what this note here exactly says. Again, in the second example, if we see this, in here we can see that the whole array is in descending order, which means the stock price is continuously decreasing. And obviously there is not going to be a way to make a profit in this case, because you will always end up buying higher than you can always sell, right? So given this, and let's actually take a look at the constraints. So the constraints is that the length of the array can be anywhere from 1 all the way to 10 to the power 5, and each of the price would range around 0 to 10,000, which 10 to the power 4. So that's what we have here. And what we are going to do is firstly, let's think about the brute force solution. So that would be the first method. So what we are going to do is that in this brute force method, the solution is going to be pretty straightforward. We will aim to find the maximum difference that we can get by buying a stock on a particular day and selling it on another, using, basically we have to do it in 2 for loops. So how this would look like is something like this. So for I in range, and we give the length of prices, which is the array, and we have another for loop inner loop which runs for j in the range of the prices. What we're going to do is we are going to calculate the difference between the two. So if j minus I, and we need a variable to actually keep track of what is the maximum profit we have seen so far. So I'm going to create a variable called max profit. So far it's actually 0. And if we find something that's more than max profit, then we are going to update max profit to this difference. So prices j minus prices I. And at the end of it, we are going to return max profit. And this is as simple as it is, right? So let's actually go through the code. So we have actually run the first for loop from the start of the array all the way to the end of the array. And j is also going from the start to the end of the array. But that actually doesn't really add up, because we can only sell a stock after we have bought it. So in this case, what we need to do is actually to tell that j can only run on an index that is after I. And for that, we will start the inner for loop 1 after the ith index. And the maximum it can go to is to the end of the array. So with this boundary, it makes sense now. So let's actually see if this runs. And we can see the solution is now accepted. But let's actually analyze this. So in this, because of the 2 for loops, what we are actually doing is that it's a very simple, straightforward solution, but our time complexity is actually pretty slow. Because of the 2 for loops, we'll be actually approximating to a time complexity of O(n squared). And while we have not used much additional space, which means our space complexity is O1, which means it's constant time, because we only keep one single variable here, we definitely need to do better because our time complexity is pretty slow. So thinking about this, we can actually take advantage of some of the restrictions that we are given. For example, we can only sell after we have bought, which means this whole when we actually iterate through the array, it's always a forward looking thing. So when can I buy the lowest and when can I sell the highest? So that is the basic premise of this whole question. So instead of this, what we are going to do is let's try and attempt to do this a in a faster way. So let's keep track of two things. One, I want to get the lowest price. So min price is going to be here. And number two is the max profit. I need to keep track of these two variables. I need to initialize min price to something that is huge when we first start. So what I'm going to do is I'm going to import this library called sys, which is system in short. So sys dot max size. This will give me the maximum possible value here. And the max profit we can just simply initialize to 0. Now let's think about it. Let's iterate through the array for I in range len of the prices. So let's think about the two conditions that we might encounter. One, we might encounter a current price which is less than the min price, which means, hey, I actually found something that's lower than what I already have seen before, which means this is the lowest so far. That means I can actually go ahead and update min price. So let's do that first. If the current price is actually less than the min price, then let's go ahead and update our min price to be the current price we have seen. But in the case that we do not have a price that is lower than the min price, that means actually we have purchased it before at something at a lower price, which means it's actually an opportunity for us to sell. And to see if that is a good selling opportunity, we need to see if we can maximize our profits. And that's where we check if this price minus our current min price is actually more than the max profit. Then that's amazing, because we have found a day where we can actually sell the stock and make an even greater profit. So we're going to update max profit to be the current price minus the min price we have so far. And doing this, we would actually keep track of the min price and the max profit, and at the end of the entire loop we will actually get the max profit. So we can simply return that here. So let's go through the code once again. We are actually looping through the entire array, and we are actually checking for two different conditions. Number one, is this the actually lowest price I've seen so far? Which means if it is actually lower, then I'm going to actually update my lowest price so far. But if it's not lower, if it's actually more than my min price, what I'm going to do is I'm check if it's a good selling opportunity by seeing if the difference is more than my max profit so far. And if it is, I will update it. And at the end of it, what I should have is the maximum profit I can generate out of this entire sequence of stock prices. So let's go ahead and run this. Firstly, let's check if this runs. And great, it runs. So this is the accepted solution. And now let's actually look at the time complexity. So looking at the time complexity, what we see is that we are going through the entire array, or in Python it's called a list, exactly once. We're going to touch each element once, and this gives us a time complexity of O(n). Have we used any additional extra space? So we have used a few variables, but that's going to be constant time. So that's going to be a constant time. We have not used any additional data structures to actually store more than constant time space. So there we go. So this is a solution for one of the most common interview questions. It's called the stock market problem, or in Leetcode it's called the best time to buy and sell stock. Again, if you go into right from basics, under the coding questions section, under the stock market question, we can see that I have already given a description. I've explained the brute force method that we went through, and also described the optimized version that we can actually run through. So I hope this video was really useful, and I'll see you guys in the next video.